We are MAGDI, AHMED, and KHALID. For assignment 2, we built a CORDIC processor in Verilog. It computes sine and cosine with no multiplier need. This video shows it how it's built and running in Quartus 2. CORDIC rotates a vector towards the target angle. 16 small steps. Each step only shifts and adds, never multiplies. After 16 steps, x and y become cos and sine respectively. Everything uses Q2.14 fixed point. 1 sine bit, 1 integer bit, and 14 fraction bits. 30 degrees, so that 30 degrees becomes 8579 in this format. No floating point needed anywhere. Okay, let's open Quartus. Here is our project. We have 3 files: the top level, the control unit, and the Datapath Unit. Let's look at the top level first. This is the top level file. It just connects two pieces: the control unit here and the Datapath Unit here. Ahmed will compile this and show the schematics.
Thanks, Magdi. So now let's synthesize our circuit and design and see if we have any errors and see the resources. So after we run the synthesis, we can see there is no errors. We have total logic elements of around 300, total registers around 90, and we have no multipliers. So now we are going to see the RTL viewer to see the schematic. So we can go to the RTL viewer. We have at the top level, we have two elements, the DU and CU, the control unit and Datapath Unit. So if we open the Datapath Unit, we can see all the adders, the shifters, the multiplexers, everything we built and designed is actually there. And we can go to the control unit and we can see the state logic we wrote. So now let's go to the machine state machine viewer. And this is the state machine viewer. It's generated straight from our code. 4 states, load, ideal, and that wait for start. And we have load, sets up the data path. We have calc, loop 16 times. We have done, which means finish the results. So the design compiles clean, schematic matches what we draw and what we coded, and the state machine also matches what we draw and coded. So Ahmed now will show you the results on the test bench and validate our design. So thank you.
Okay, and as you can see, this here is our test bench. We will be testing 4 different angles, to be exact 30, 45, 60, and 90 degrees. Here is their Q format equivalent, these 4 values, and we will use the ModelSim-Altera to simulate the test bench. Let it load out. Close, and I'll press the command so that I can run the test bench. Let it load up. No. Okay. So here is our waveform. 1 second. Okay, let me zoom out. As we can see, here are you can see the clock, the reset, our input and output, everything. If we scroll down, we can see the value changing inside the Datapath unit. If we zoom in a bit, Zoom again. Yeah, so we can see the different iterations. If we count, there will be 15 iterations, same as our algorithm. So the first input we put in here in theta was 8579, and which, if we compare to the Q format, is the equivalent to 30 degree in radian. Yeah, we can see the 15 iterations, it updating the value, and then the final signal, the done signal up here, to indicate the output coming out and the change of state from in the state machine. And here is the cosine output and the sine output, which are these two values. That's for the 30 degrees, which is 14,191. If we compare, we can see only a two-digit difference between the two values, which is equivalent to 0.5 and 0.86, which is how we confirm that our model is working. And then there is the same for the 90 degrees, for the 60 degrees, the 45, the 60, and finally the 90 degrees. For the 90 degrees, we can see that the output is equal to 2, which is the closest thing to 0, close enough, only 2D difference, and 16383, which is equivalent to the value 1, only a 1D difference. And that will be all. We have verified our system for the CORDIC digital system algorithm, so we can compute sine and cosine without using multipliers. Thank you.